All right, I'm going to be doing problem number 11 from chapter 2 in your book. It describes you are trying to get to an interview in a different town and you had to drive at different speeds due to construction and things like that. What we try to do when we set up any of these problems, and anytime you set up a problem in physics, it's always a really good idea to sketch it out. This one is written out in words and there's no actual picture that goes along with it. So I'm going to draw a couple of sketches to kind of help me out. The entire distance that you need to drive for the interview is 300 kilometers. So the distance that you need to travel from your initial point to your final point is 300 kilometers. Right? 300 kilometers. Hope that can be easily seen. You travel 100 kilometers per hour for the first 100 kilometers. So 1/3 of this distance, I'm just going to kind of sketch out a little bit. It doesn't need to be exact, right? We're just drawing a little bit of a sketch. And during this time, the velocity of your car is 100 kilometers per hour. And you can even think, right, how long is that going to take us? It's going to take us, 1 hour. We could determine that by figuring out how much time it would take to travel 100 kilometers, traveling at 100 kilometers per hour. And we could plug that into an equation, but it kind of makes sense. We could plug that into this relationship, that the velocity is equal to the displacement over the change in time, where solving for the change in time would tell us that if we traveled 100 kilometers at 100 kilometers per hour, and I keep getting text messages, that indeed it would take 1 hour of time, right? The question doesn't actually ask that, but that's something that we can tell from the information that we are given. It also tells us that for the next 40 kilometers, so here would be 200, so let's say 40 is right here. So for the next 40 kilometers, we're forced to drive 40 kilometers per hour. I'm just going to write these with subscripts of V1 and V2. And hopefully you can see that okay. So what that means is that how long is it going to take us to drive that second bit, right? The second segment of this time, we're traveling 40 kilometers, a distance of 40 kilometers at 40 kilometers per hour. Well, again, you can probably tell from the same type of thing. We could actually calculate it out, but we can almost infer that this second time interval is also going to be 1 hour of time. Now, the situation tells us we left at 8 a.m. and we need to arrive at our interview by 11:15. And so we need to know how fast to travel in order to get to the interview on time. So it may not be we're given all the information that we need, but it may not be obvious at first what we actually need to find out. Right? What we want to know is the velocity, this v3 during this, I can't draw question marks, during this last interval of time. So we don't exactly know what this distance is right from the beginning. We're not at least given that information. And we also don't know exactly how much time we have to get there, right? But we can figure this out. We know that we left at 8 a.m., so we have 3 hours and 15 minutes to get there. Well, we already used 1 hour and 2 hours, which means we have 2 hours and 15 minutes to get there. And just to convert that into a decimal, or something that's a little more useful, we have 1 hour and 15 minutes, which 15 minutes is 1/4 of an hour, right? So 15 minutes out of 60 minutes would be just 1/4, right? So I'm going to put 1.25 hours that we have. And in terms of distance, we can almost do this in our heads, that we have 300 total kilometers to travel, and we've already traveled 140 kilometers, so that means that our remaining distance here is going to be 160 kilometers. So we have 160 kilometers to go, and we have 1.25 hours to make up that distance. So we need to know how fast do we need to travel. So now we've basically kind of, it seems really obvious now. The reason it seems so obvious is because we kind of took our time and drew out this sketch. You might be able to get the same type of information by just reading it and thinking about it a little kind of quickly, but it's helpful to sketch this thing out. I'm not doing this simply because I'm trying to show you the way you should learn how to do it. This is how I would do it. This is exactly how I would solve this problem to make sure that I'm keeping track of everything. So now we just need to solve, right? We know that the velocity, the average velocity, is going to equal to the displacement divided by the change in time, and we know what those quantities are. Since these other quantities were given in kilometers per hour, we'll just keep this in kilometers per hour as well. Right? We know that the displacement is going to be 160 kilometers. we're going to divide by 1.25 hours, and we can actually figure out what that quantity is, right? It would be, oh, what would that be? I don't have a handy calculator on me. Let's see, this is exactly the same thing as 5/4, right? 1.25 is the same as 5/4, so we can do a little bit of estimation. So if we took this top number times 4, that would be 0.428,104 divided by 5. Is that right? No, I screwed that up. 426. This should be 640. Sorry. 640 divided by 5. That seems a little bit better. That's going to be something like 100 and let's see, that's 5 and 1, 14, almost 130 miles per hour, kilometers per hour. It's going to be just a little bit shy of that, so just a little bit less than 130 kilometers per hour. So that's just a quick estimation thing I did there at the end. But you could calculate that out, right? So this is how we would solve this particular problem. Notice that having the sketch initially helped, and also kind of getting some information as we went along was also kind of helpful, and led us to this really nice solution, which we can then check, right? We can use units to check. Notice that this was displacement was in kilometers, and this was the time was in hours, and our final answer is kilometers per hour, right? Which is what we would expect to have for some type of velocity. So there's a nice check on the units that we can do, and it would also make sense that we have to go probably faster, right? We have more distance to make up in a little bit, less time. If we wanted to travel just 100 kilometers per hour again, we would need 160 or 1.6 hours to travel that distance. So we obviously have less than that. So that makes sense why we'd have to travel faster than we did initially.